Welcome, everyone. Thank you for attending one of the free training events that we do at Tigera. Today, we're going to be going over getting up and running with Calico in an on-prem environment. Well, good evening as well, I suppose, if people are in other parts of the world. I'm located in US East 1. I'm in Northern Virginia. My name is Jonathan Sabo. I'm a senior solutions architect at Tigera. It is January 2021, so everybody, Happy New Year. Here we go. Let me see if I can figure out how to use PowerPoint here. So I'm guessing the majority of the people here are familiar with Project Calico, but if not, Project Calico is a networking and network security and observability solution for Kubernetes. It's an open source project. We also have an enterprise product built on top of the open source project. We'll talk a little bit about that as we go. You can find us at projectcalico.org or tigera.io. If you want to follow us on Twitter, it's at Project Calico or I believe at Tigera. If you're interested in participating in the project, if you can program in Go and Python, you can join in on the fun at github.com/Project Calico. And then just kind of, you'd be one of, at this point, probably 150 or so different people who are contributing to the project. A lot of industry professionals and just people who like to contribute to open source projects. If you're interested in, or if you're interested in just kind of learning more about Kubernetes and Project Calico, one of the, and if you have questions that I don't get a chance to answer today, you can join us at our Slack, and it's slack.projectcalico.org. There's well over 4,000 people on our Slack. A lot of the people who have been running production Kubernetes clusters across various financial organizations, heavily regulated industries. We're a small company with very large customers, and Calico is by far the most widely used CNI in Kubernetes. I think that there was a Rancher study that was just released that did a poll, and you could see the bar graph was like very high for Calico. We power over 1 million nodes, over 200,000 known public clusters. And today's agenda, we are going to go over some Kubernetes networking considerations, some Calico networking considerations. We're going to install Kubernetes with Calico using kubeadm. We're going to explore Kubernetes with Calico networking. We're going to look at a very simple Calico network policy. And all of this is at the URL that you see below here. We email out the slides at the end of the sessions in addition to the video. Let me take a look at some of the questions. I think one of the questions is, one question is, can I get older session recording? This is actually a repeat of a session that we've done before. So if you go to our YouTube channel, there's a Project Calico YouTube channel, and we have some really awesome videos that explain how packets move throughout a Linux, a Kubernetes cluster in AWS or on GKE or in Azure and AKS, and how Kubernetes services work and how ingress works. Our CTO, Alex, did an awesome job on those videos. I love watching them, and I recommend you watching them as well. We also have a Tigera YouTube channel, and that's where we post these training sessions afterwards. So you'll get an email with the video and the slide decks. But if you just want to subscribe to our YouTube channel, you can go and back and watch all the other YouTube videos that we've been doing over the past year or so. Is this demo on the community version or enterprise? It's going to be both. We're going to start off with Calico open source. And then if we have time at the end, I'll probably show off the enterprise version a little bit and just kind of show you how you can sign up and for the enterprise trial if you want to try it out in your own clusters, or we also have like a hosted version if you just want to use our hosted version too. All of this is free. So let's get into this. So Kubernetes networking considerations. Well, the first one usually is what distribution am I going to use? There's so many. There's Rancher, Tanzu, OpenShift, I don't know, kubeadm, which I'm going to be using today, and probably many others. RKE. There's like all kinds of different Kubernetes distributions. And one of the things that you consider is, hey, will my CNI work with this distribution? And is it a supported CNI? One of the things that you'll find is that Calico is typically baked into almost every almost every Kubernetes distribution. If it's not the default CNI, it comes with, it usually is baked into the product in some way or shape or form. If you are hosted, if you're using one of the managed Kubernetes services in one of the various clouds, AWS, Azure, GCP, the Google Cloud. We are partnered with all of the public clouds, and we are either in IBM as well. We're either powering their Kubernetes infrastructure, or we are a supported option for either networking and network security. Usually, if you type in the cloud name and then Calico, hit enter in Google, you'll see it pop up, and you'll be able to join us. We actually just launched an AWS Quick Start. You probably see that floating around LinkedIn and the Twitter sphere. I definitely encourage you to take a look at that. It's a really easy way to get going with Calico on EKS and then Calico Enterprise as well. So after you've decided, hey, this is the Kubernetes distribution or OpenShift or the Kubernetes implementation that you're going to be using, you want to decide which CNI I want to use for my cluster. So a lot of people will start off with Flannel, and then maybe so one of the consideration really is, do I just need networking, or am I going to need to do network security policies? Am I going to need Kubernetes network policies? And then do I need to have advanced features that Calico network policy gives you? For a while, I think like the default, I mean, it might even be the case today. The default CNI for Rancher cluster might be Canal, if not Flannel. And so we see a lot of people start off with one or the other, and then eventually migrate to Calico if they didn't just start off with Calico. And the consideration is really, do I need networking or do I need network security through network policies? The answer really is you're going to need network policies eventually. When you try to go into production, the security teams will get involved, and they'll say, what do you mean everything can talk to everything? We have these things, we have these firewall things outside in the data center, which have really no visibility or ability to do enforcement inside of a cluster. So you need Kubernetes network policy really to secure things inside of your cluster. And Calico provides that. So Calico is a great choice for a CNI. In addition to that, you get tons of observability tools and troubleshooting and all kinds of stuff we'll show you in a little bit. When you're choosing with some of the other networking considerations, you need to decide. So when you create your Kubernetes cluster, there's a couple of different network siders you need to pick. One of them is the pod sider. These are going to be the range that IP addresses are going to be allocated out of to assign an IP address to pods. Pods are the ephemeral deployment unit inside of Kubernetes. You containerize your applications, you create deployments, which basically create pods. And these are the ephemeral instantiation of containers inside of Kubernetes that Kubernetes orchestrates around from node to node to node based on availability, memory utilization, CPU utilization, other metrics. And so you have to think like, okay, well, how many applications am I going to have in this cluster? How many nodes am I going to need inside of my cluster to be able to support that? And then how many pods am I going to be able to have on a single node? And will I have enough IP address space to be able to give IPs to all of those pods that are going to come up on the different nodes? Kubernetes has like a top limit that I think that they set. I forget if it's 2,000 pods per cluster. I'm probably messing this up, but you should check your distributions documentation. A lot of times they'll have hard set limits on how many pods can run on a particular node. Sometimes it's a little arbitrarily decided, and you can change that either at install time or after the fact. Sometimes it's after the fact, and if that's the case, you might have to rebuild your cluster. And so it's a good thing to like think through these things when you're planning out your Kubernetes installation. And how many pods you're going to be able to support on a single node are going to depend on how much memory and CPU you have on that node. And then there's probably some other considerations too, like depending upon like the application, the security zone it might be in, or some other considerations. But from a network standpoint, the one of the big thing is like, am I going to have enough IPs to be able to assign IPs to all of my pods? So you have to decide how big should the pod CIDR be. Another consideration that you'll want to think through upfront, but this can actually be changed after the fact, and we'll talk a little bit more about that as we go through, is whether or not the pod CIDR and the service CIDR will be private or externally routable. If you're deploying in an on-prem environment, and you're collaborating with your network team, you have some superpowers that Calico provides that you could unlock to be able to expose pods and services on your IP network and kind of make them first-class citizens on your network by BGP peering with your top or rack switches. Maybe you might be like in a colo, something like Metal, or what is it called? There's a couple of different colos that allow you to peer with your network infrastructure. Or you could be in a cloud where that's not possible, something like AWS. You're not able to, unless you're launching like virtual appliances inside your environment, you're not going to be able to appear with like AWS's infrastructure. So, well, the choices here are: will my pod CIDR be private, or will I make it externally routable? And if it's private, what that really means is as traffic leaves the cluster, as traffic leaves from a pod to running on a specific node, and it exits that node out to some external destination, it's going to get source NATed to the IP address of that node. And that's going to change as it goes from node to node to node. If it's externally routable, it will be the IP address assigned to the pod. And there's some different use cases and advantages of actually both choices. One, if it's private, it can let you conserve IP addresses, which are a finite resource. Maybe your networking team is not going to hand out CIDRs for all the clusters, or maybe they're on board with that and they want to have non-overlapping IP address space for all the clusters, and they're going to make things routable, and that unlocks a bunch of different features in Calico and then also in Calico Enterprise. So definitely consider which you're going to choose, and we'll talk a little bit more as we go. The next networking consideration you will want to decide is the service CIDR. So services are load balancers that sit in front of pods. These are a construct that give you a couple of different things. Service discovery: when you create a service, you get a DNS name assigned to the service that's internal to the cluster. It's like the service name .namespace.clustername.cluster.local. And also you get a well-known IP address that's going to stick around. The services are not ephemeral. The pods behind them are. And the services in most clusters are typically implemented by this thing called KubeProxy. As time goes on, there are exceptions to that. Specifically, well, one of them is if you're using Calico with our eBPF data plane, we've implemented the functionality that KubeProxy does inside of eBPF, so you don't have to. You don't use KubeProxy anymore. But if you're using the standard Linux data plane, you will have a KubeProxy, and what KubeProxy does is it will redirect traffic, inbound traffic to a service to pods behind the service. If you look on the right of the slide, you'll see host 1 and host 2, and the little circles there on the left. Those are the services, and they load balance to pods behind them. That if you do kubectl get endpoints and then the name of a service, you'll see the IP addresses of the pods that are being load balanced behind that service. And as you start to scale out the number of services in your cluster, or if you were planning up front, like how many services am I going to have inside of my cluster? Am I going to have more than 2,000? Am I going to have 5,000? At a certain threshold, you may start to see a performance impact based on the choices you make. We actually have a blog posted on our blog.tigera.io that kind of goes in depth on some of the performance benchmarking that we've done, comparing the different modes and kind of going through. And basically, I think we looked at like the first packet, because after that, I think it's pretty much the same between IP tables and IPVS. But there's like the very first connection gets set up. There is at a certain scale, there is a difference in, I believe, latency between IP tables and IPVS. That's one of the reasons why IPVS was added in here as a KubeProxy mode. I believe the default though for kubeadm is still IP tables, and that's fine until like a very large scale. Definitely check out our blog on that. It's on our blog.tigera.io. Maybe I'll pull up here afterwards. But so these are the things that you're going to want to decide. You're going to want to have your pod sider, your service sider, and you want to make sure that they're non-overlapping. You don't want to have the same network sider for your pod and your service sider. Those need to be different. And if you have more than one cluster, and today, everyone is going to have more than one cluster for various reasons. You're going to have one for dev, one for QA, one for prod, probably a bunch for each one of those environments. Maybe you have clusters or one or two in different regions across the world. And that's when like multi-cluster management stuff comes into play. But it can be advantageous to make sure that the network sider and the service siders are non-overlapping as you create new clusters. So keep that in mind. And then also you're going to want to decide which KubeProxy mode that you use based on the amount of services that your cluster is going to be supporting. And then the Calico networking considerations. Which Calico data plane do I use? Today, we have 3 different choices. We have the standard Linux data plane, which is just Linux networking. Basically, Calico is writing into the kernel as part of, like, we manage as part of a management plane. We create routes in the Linux kernel. So we're not really like in the data path. We're just kind of programming the Linux kernel and directing traffic around. So it's a very fast data plane that you can use today across all of your Linux nodes. And so if you're running like RHEL 7, or if you're running like slightly older versions of Linux, that is probably your best bet. But if you happen to be using one of like RHEL 8 or one of the later versions of Ubuntu, you'll have the ability to use our latest data plane, which is our Calico and Calico Enterprise eBPF data plane. And that supports, it's a new technology that provides higher throughput, lower latency, lower CPU utilization. It's kind of like the new hotness you probably be hearing about all over the Twitter sphere and LinkedIn now. So definitely check that out. I think we'll show some links to that in a little bit. And we also have, if you happen to have Windows workloads, we have a Calico supported data plane for Windows. So you can join your Windows nodes to your cluster and have connectivity amongst your Linux Kubernetes workloads. We open sourced our VXLAN tunneling Windows support first. And then we came back and we open sourced our BGP Windows networking. So if you're on-prem and you are peering with your top of rack switches, Windows is now welcome to the party. So once we've chosen our data plane, whether it's the standard Linux data plane, the latest, greatest Calico eBPF data plane, or I've got Windows nodes, so I'm going to have the Windows data plane is in the mix as well. Then we have to decide, do we need to do network encapsulation? And there's a couple of different considerations as far as whether or not you need network encapsulation. One, do you want to use network encapsulation? and there's scenarios where you can choose not to do it. One of them is if all the nodes are on the same subnet, the same layer 2 segment, they can all talk to each other via layer 2. So they don't need to do encapsulation. You can just turn off network encapsulation. Calico provides two different network encapsulation methods, IP in IP, I think it's IP protocol 4, and also VXLAN. So you get to choose between the two. IP also uses BGP. It's a very low overhead, performant tunneling mechanism between nodes. And so if all of your nodes happen to be not on the same subnet, you have them split across racks in your on-prem data center, and there's different VLANs in the different racks. Well, the network's not going to know about the pod CIDR unless you're peering with your top of rack switches. So the only way for to pass that traffic across those layer 2 boundaries, across those different network boundaries, is to tunnel from node to node across those network boundaries. So imagine you have VLAN A in one rack and VLAN B in the other rack. Calico you can have so say we choose IP. We can have IP always on, so if we're always going to do tunneling, or we can say cross subnet. So the nodes that are on the same layer 2 network, the same VLAN, they're not going to do encapsulation. But when they need to make connections across that network boundary to the other rack, then they will get tunneled through IP. So it's kind of like a smart way of minimizing the overhead incurred by network encapsulation. If you happen to have your nodes deployed across racks and they're on different layer 2 or layer 3 segments across your data center infrastructure, you can choose to peer with the top of rack switches, and then you don't have to do any type of encapsulation. So there's many tools in the toolbox for your deployments, and these are all considerations that you will want to take into account when you're planning out your Calico Enterprise and Kubernetes deployments. So what do I use for the initial IP pool CIDR? So we talked a little bit about IP pools. Excuse me. We talked a little about pod CIDRs. So and then service CIDRs. So when you're using Calico, there's a third CIDR that you get to choose. So typically people say we assigned a /16 for the pod CIDR 10.0.0.0/16, and then we do 10.1.0.0/16 for the service CIDR. What we can do is we can take a chunk out of that /16 and we could create a /24 for our first IP pool. And what IP pools do, hold on 1 second here. Let me just make this go away. What we can do by choosing to create an IP pool that's a small chunk of the pod CIDR, it allows us to create more than one IP pool. By default, if you don't choose a smaller network CIDR for your IP pool, Calico is going to pick the entire pod CIDR. And you can change this after the fact, but it's better to just plan up front and say, hey, I'm probably going to want to have more than one IP pool. And so why would I want to have more than one IP pool? Well, with Calico, you can do things like assign an IP pool to a namespace. So when pods come up in namespace dev, they get an IP address out of IP pool A. So they get an IP address out of 10.0.0.0/24. And then you could say, I have namespace QA or test. And you can say pods that get launched into that particular namespace, they get an IP address out of this other pool, 10.1.0.0/24. And so that allows you to give well-known IP addressing to workloads based on the namespace that they're in. You can also do this via even to pods. In the real world, though, we typically see people using this for namespaces or nodes. You can assign it's all based on labels, but you could say, hey, these nodes get pods that are going to run on these particular nodes are going to get IPs out of these particular IP pools. And there's a lot of reasons why you might want to slice and dice between nodes and namespaces and things like that. Also, if you happen to be using Calico Enterprise, we have this thing called egress gateways, and that will require, the egress gateways will require an IP pool. And what that allows you to do is kind of when traffic leaves the cluster, it can get source natted to a well-known IP address and not the IP address assigned to a node. So there's a lot of reasons why you would want to create more than one IP pool. I would suggest starting off with a IP pool CIDR smaller than the pod CIDR. So those are the three things that you really need to come up with. Well, four, you need to know the pod CIDR, the service CIDR, the IP, the kubeproxy IP tables mode, and the initial Calico IP pool. And then do I want to assign specific IPs to pods based on nodes and namespace? We kind of went over that. What initial IP pool block size should I use? Yeah, so IP pools, when you create them in Calico, the default block size is /26. So say we've created a pod CIDR that's a /16. We've created an IP pool, it's a /24. When we have 3 nodes, so when Calico node comes up on each one of those 3 nodes, what it's going to do is going to say, hey, what is the block size for this IP pool that we have? If the default is /26, and what it's going to do is going to allocate out of that IP pool a /26, and it's going to assign 1 to each node, and we'll see this in a minute. Sometimes you might want to change that. You might want to make it smaller or larger for various reasons. And honestly, if some of this stuff can sound a little overwhelming, don't worry. We're here to help. You can join us on our Slack and get help as we have time throughout the day. But we also offer support for this stuff too. So if you're planning out your cluster deployment and you want to have some experts on your shoulder, on your side that you can call and ask about this stuff, feel free to hit us up at tigera.io. We're definitely down to help. And then, should I disable NAT outbound? Well, and this comes back to whether or not your cluster is going to be private. So, and this is kind of the determining factor. Will I not be natting traffic as it leaves my cluster? If you appeared with your top of rack switches and you decided to make your pod and service side or public, you can disable NAT. You don't have to NAT outbound. You don't need to do that. But if you're going to use the network encapsulation and you are going to keep your cluster CIDRs private, then you're going to need to have NAT outbound enabled. And this is a per IP pool setting. And one of the reasons why people choose to keep another one to keep your cluster pools private is sometimes you just want to use the same network blocks again and again and again for each cluster. Like if it would just make them all the same. Maybe it's operationally the operational overhead of tracking and maintaining non-overlapping network CIDRs for all the clusters that I'm going to have across my organization becomes taxing. So we're just going to say they're all the same, and we're just going to keep them private. So these are some of the considerations that you will want to take into account as you start to do your deployments. So Calico network policy, it secures applications by enforcing which network traffic is allowed or denied using label-based rules. So by default, when you install a CNI, all of the pods will be able to talk to all of the other pods, and they're going to see the source IP of each pod. There are no rules. You can all of the workloads you deploy to your cluster can talk to every other workload inside of your cluster. And as you start to move beyond like a sandbox environment, a dev environment, and you want to start to segment workloads from one another, you're going to want to have a way to say, hey, these workloads should be able to talk to these workloads, but not these workloads. Traffic coming in from outside of the Kubernetes cluster should be able to talk to just these workloads and not any of the other workloads. You need to create choke points and kind of implement the security controls that you see implemented across the standard data centers today, and implemented with things like firewalls, IDF sensors, stuff like that. Unfortunately, those network access controls don't have any ability or have any view inside of Kubernetes clusters for the most part. So you need something like Kubernetes network policy and Calico network policy to be able to facilitate that microsegmentation, to be able to create that zero trust network paradigm for your clusters, to be able to start off with like default deny policies, either for every namespace or the entire cluster. And so that's a couple of the reasons why Kubernetes network policy is important. It allows you to meet the security criteria that you're going to have to meet to actually take your applications from dev in these sandbox environments and move them into a production-like environment. And there's much more required to be able to do that. And that's kind of the stuff that Calico Enterprise delivers on. There's you're going to need a lot of visibility and a lot of ability to kind of report on the compliance and the adherence to your network policies. So what's special about Calico network policy? Well, Calico network policy is it's like a superset of Kubernetes network policy. It builds on top of it. It's its own implementation, but everything you can do with Kubernetes network policy, you can do with Calico network policy and more. Calico network policy allows you to control not just inbound access, but also outbound access using label selectors that are applied to pods, namespaces, or service accounts. And the ability to manage labels to namespaces and service accounts can be controlled by Kubernetes RBAC. Calico network policy also has some really cool operators. I think like has, like you say, like has the label dev should be able to talk to has the label dev, but not has the label prod, things like that. And so it allows you to implement the zone-based architectures, the same segmentation patterns that might be standards at your organization, and kind of model those again in a label-based manner. In Kubernetes, Kubernetes is very ephemeral. There's way more endpoints there's way more pods than there would be VMs, and things move continuously. So using like IP address based identity for a workload just isn't going to work out. So you need to be able to use Calico and Kubernetes network policy, which are based on the Kubernetes metadata, the labels, to target workloads, because those are the things that are going to be that are not ephemeral. They're going to follow those workloads around and use those as target workloads to apply network policy, to enforce your network supply, your network policy, so you are in compliance with your security team's security criteria. And so we have a simple example here, and we're going to show some a little bit. One that allows flows from like the least secure zone to the most secure zone, something that most of us have probably seen in our careers. You have a DMZ that probably allows inbound access from the internet or from outside of the cluster, and then that from the DMZ. The trusted zone is allowing inbound connections from the DMZ, and the restricted zone is allowing inbound connections from the trusted zone. And so it kind of goes from like least secure to most secure. What we're going to show here is like a simple Calico network policy example. You can see this is just an application that a simple three-tiered application. You've got a front end a service that implements like a web UI, and that speaks behind it to a couple of different supporting microservices that implements the business logic of this particular service, and then those connect back to the back end. And you can see what we're going to do is we're going to segment them from one another. And so the connections into the cluster from outside of the cluster are allowed to only come to the front end and into the DMZ zone. And then the front end is going to be allowed to talk to the trusted zone. And then the microservices will be allowed to talk to the back end. And we'll have three different zones: DMZ, trusted, restricted. So we're going to get into the demo now in just a moment, but before I do that, I'll kind of go through, we have some upcoming events. You are attending here today. It is January 14th, but on the 19th, we have a couple of different talks going. We have Understanding Case Networking, Fireside Chat with AWS K8s experts. I would definitely attend that one specifically. It's going to be really good. Enterprise Security Controls for K8s, leveraging the power of Calico and Fortinet. If you happen to have Fortinet devices in your on-prem environment, we have integrations with Fortinet and also Palo Alto. And so you can see how to secure any application on any cloud. I'm going to be back on the 28th doing a multi-cluster management, federated identity and services. So the services we talked about, you can actually create services across clusters without a service mesh, just using Calico. As part of Calico Enterprise. And so we'll be getting into that, and I'll be demonstrating that. And then I think that I just copied the last bullet point twice. And if you're not aware, we have an introduction to Kubernetes networking ebook that's really good information. Definitely check that out. And if you're not Calico certified, you can now get Calico certified. And so there's already hundreds and hundreds of people who are Calico certified out there in the world, and adding that to their resume. I see people posting it on LinkedIn all the time. It takes you through a really good course and kind of tests your Calico knowledge, and it allows you to kind of go through all of the different certifications. Let me just take a look at some of the questions. Are there multiple levels to the certifications? There are definitely multiple. There's one certification today. There'd probably be more coming. So, Steve, are you already certified? If you're already certified, I'm curious. How many people are already certified? Not yet. Well, me neither. Either I haven't had a chance to go through it. I've gone through it, and it's a really great course. But we all should get certified. Yeah, it does look good. A lot of people are raving about it. Hello from Amsterdam. Hello from Northern Virginia. Is Calico NetPol a CRD? Calico Network Policy is a YAML file. Calico Enterprise is managed by CRDs. There are definitely Calico Enterprise CRDs, but Calico, yes, Calico Enterprise, Calico Network Policy is just a YAML file that you apply to your cluster. It's not a CRD though. Can you share the links for the Introduction to Kubernetes ebook? Everyone that's here today will get an email with the slides, and you will have the links available to you. I would like to see a webinar where you show how to interconnect pod siders of 2 case clusters running Calico. If you want to see how to connect the pod siders of 2 clusters with Calico, join me on the 28th, because that's what I'm going to do. All right, so enough slides. Let me just toss this into the chat. Do this here. All right. So what we're going to do is kind of just run through. So first of all, this is the getting up and running with Calico on your on-premise case cluster. This workshop was built for training workshops. If you're looking for general docs, we recommend that you start here. And what here is the quick start for Calico on Kubernetes. So I maintain this. This is maintained by our engineering team. So this is definitely the best place to start. If you're just getting started with Calico, you want to know what's the latest, greatest, come to our docs. This is the open source docs, and follow along. Our open source quick start starts you off with VXLAN tunneling between the nodes. What I've done is we've kind of gone through and listed out the considerations that we went over, and we're going to build out a cluster with some slight differences here. So you can see the Kubernetes networking considerations that we talked about before. We need to choose a pod sider. We need to choose a server sider. We need to choose which KubeProxy mode to run. And then we have to the Calico networking considerations. Which data plane are we going to use? Which IP pool sider are we going to start off with? What is the block size that we're going to start off with inside the IP pool? Will we have NAT outgoing on or not? Is this going to be a private cluster, or is it going to be a public cluster? And then how to determine whether or not encapsulation is required. Are all of our nodes in the same subnet? If they're not, they're spread across racks, and we're going to need to have encapsulation. So in a minute, we'll see where are our nodes located. And then we're going to install Calico using kubeadm. We're going to explore a little bit of Calico networking, and then just do a really simple network policy. We've only got 20 minutes left, so I'm kind of go through this. So I've gone ahead and I've made some decisions up front. These are the pod sider that I'm going to use is 10.48.0.0/16. And then the service sider I'm going to use is 10.49.0.0/16. And I'm going to use IP tables mode. So I'm going to start off with, so you can just see that they're non-overlapping. They're 2/16s, and they're non-overlapping network siders. And for the Calico data plane, I'm going to use the standard Linux data plane. For the initial IP pool, I'm going to pick a /24. out of the /16 up here. So I'm going to pick a net block out of the pod cider, and I'm going to start off with that. I'm just going to go with the default /26, and I'm going to leave NAT mode enabled. And I have an additional IP pool, kind of just to show that you can create more. It's committed to this Git repo. I don't know if I'm going to go through that though. All right, and then so what we're going to do now is I'm just going to kind of go over the high level tutorial, and then I'm going to go and just do it, and we're going to do it together. If you are starting off, and this is an example assuming that all of your nodes are Ubuntu 18.04 LTS. It's free. A lot of people should use other distributions. If you have access to Red Hat or CentOS, that's great. This works. What I have here is set up to do Ubuntu 18.04. I'm installing things with apps. And you can see how quickly you can get up and running with kubeadm. It's just a couple of commands, and you run this across all of your nodes, and then you can see all nodes, and then you'll be ready to go to start to do the installation. Then what you're going to do is you're going to initialize the master node in IP tables mode with a kubeadm cluster configuration. And you'll see the decisions we made up front, the pod cider, the service cider, the IP tables mode. These are all baked into this configuration. If you're using something like OpenShift, they have like the install-config.yaml. That's the same thing. You'll need to plug these in there. And there's other decisions you have to make too. But for as far as like the networking goes, pod cider, service cider, IP tables mode, as far as like the initial initialization. And then what we're going to do is we're going to join we're going to create this on our controller node, and then we're going to join all the worker nodes to the controller node. We're going to install the Calico Cuddle binary, which is only required for the open source version of Calico. If you have Calico Enterprise, we give you an API server, and you can use kubecuddle. You don't have to use Calico Cuddle. It also gives you programmatic access to things like network policies, the BGP configurations, all the things that we're managing via like the CLI. So if you have like automation that you want to build on top of Calico for your hosted cloud service or something like that you're using Calico and Kubernetes, you're going to want to have Calico Enterprise. We give you an API server and a Swagger definition for those APIs. Makes it really easy to program against. Shows you all the different APIs that you can communicate to, and then how to do CRUD operations on them. And then the configuration, this is actually no longer needed. Assuming you're using the KDD mode. Basically, you're not talking, you don't have an external SED server. You're using the Kubernetes API to access etcd. This was a recent change, I believe, in like Calico 3.17. Now the Calico Cuddle commands, they assume you're using the KDD mode. And I think by default, look in the user who executes its home directory for the kube config. So if you're installing the latest, greatest version of Calico Cuddle, you can just install the binary and rock on. And then if you want to reset your node, you can reset them. We're going to show how to do the joins. And then what we're going to do is we're going to install Calico. So why don't we well, let me just finish going through this and then we'll go through it. And then the installation of Calico consists of installing a Tigera operator and then custom resources. Calico has a couple of different installation methods. You can install via a YAML file. We still support that for open source Calico. But we also have an operator installation, which is what I would recommend. The operator does the installation for you. It manages the lifecycle of Calico and Calico Enterprise for you. It makes upgrades really easy. It's also just the better way to go. So if you're starting out, I would say choose the operator installation. And I can see all the questions coming. I'm going to come back to those at the end. I kind of want to get through a little bit of the demo. And so we're going to install Calico Enterprise, and then we're going to take a look at what's going on, or excuse me, Calico. And then we're going to take a look at, hey, what can we do with Calico Cuddle? How can we observe this, that everything is working as it should be? We're going to take a look at the IP pools that we've created as part during our installation, and then we're going to like observe the IP addresses, and then we can see the different blocks that are assigned to the different nodes. We'll get a sense of the IP address utilization across those nodes, and then we can see, hey, what are the default network policies and the default global network policies? There aren't any. And then we're going to implement our zone-based architecture, and that is included here inside of this particular repo. And then you'll see that we've got a DMZ zone, a restricted zone, and a trusted zone. All right, so let's get going. I'm going to follow along here as well on the on our quick start. So if you come here, then this is this is where you should come if you are just starting out. What we've done is we made a couple of different decisions here. We're going to do some specific network siders, and we're going to do some specific configurations. And so let's take a look at this. So this is the Cisco Modeling Labs, and what this is a way to virtualize at real network hardware. You can see what this is it's a pretty common deployment. Well, it's a pretty common data center architecture. I think like Facebook and Amazon have probably made it famous. It's a scale out architecture for on-prem environments. You can see here we have some spine switches. And if I come up here, we can see that the spine one is connected to every one of the leafs. So spine one is connected to leaf 1, leaf 2, leaf 4, 5, and 3. So, and then we can see the same thing over here, spine 2. And what this does is it gives us redundant connectivity across the next layer of our network infrastructure. And these are the leaf nodes. And you can see that behind the leaf nodes, we have a single Ubuntu node. So we've got Ubuntu 1, Ubuntu 2, Ubuntu 3, Ubuntu 4. And we have, and so we have routed connectivity across the leafs to the spines, to leaf 5, and then out the front door, out to the internet. And if we come down here, you can see that we've got some management access that we're going to use to pull images and to do our installation. So let's start off with Ubuntu 1. Well, before I do that, actually, let me show you a little bit about the connectivity. So let's log in one of the spines. So just show IP BGP sum, and you can see that we've got full BGP connectivity here. Admin, look into this guy right here. Typing my password wrong. Show IP BGP sum, and you can see that. So we've got all the peers are up on both spines. Spine 1, spine 2 are peered successfully with all of the leaf switches. And the switches, these are Cisco. Well, let's take a look. Show version. Yeah, so these are Nexus 9. So these are 9000 series switches. It's the, where'd it go? Yeah. And so these are, I'm running the real switch OS inside a virtualized environment to kind of game out some different network topologies. And I'm, disclaimer, I'm not a network architect by design. I'm more of a DevOps engineer that happens to have had experience with dynamic routing protocols. And what we're doing here today, if you are on the call and you are a network engineer and you speak BGP, I would love to collaborate on these topologies. So if you like what you see today and you're interested in collaborating, hit me up on LinkedIn at Jonathan Sabo. I would love to collaborate on some of this stuff for training and demos. And just to kind of show the leaves, if I can log in with the right password, we'll see one more time and then I'll. You can see. So we've got full connectivity across all of the network infrastructure here. And what that means really is if we come to the console of Ubuntu 1, I should be able to ping out to the internet across these different network devices. I can ping the top of rack switch here. I can ping the spine 21. Yeah, so we've got full BGP connectivity between this infrastructure, and this also means that if I take a look, let's do if config. So we look at the F1 interface. So you can see one of the considerations that we need to determine is, hey, are all of my nodes in the same layer 2 segment? Well, based on this topology, no, they're not. This Ubuntu 1 has an IP address for ENS2 on 10.16.1.11, but on Ubuntu 2, if we look, you can see it's 10.16.2.11. If we look at Ubuntu 3, you can see (10.16.3.11), and then Ubuntu 4, 10.16.4.11. So we were not going to be able to have encapsulation turned off and just kind of benefit from the fact that we're all on the same layer 2 segment. So we're going to have to use encapsulation. And we have two choices with Calico. We can do VXLAN or we can do IP-IP. Or we could peer with the top of rack switches and then turn encapsulation off. And that's one of the things that we'll probably do in the next time we do this. We only have a whole lot of time left. So I'm going to get going here. Let's take a look at, so inside of the Ubuntu 1, actually, this is going to be my master node. And I have a couple different files here. I've got the kubeadm. Let's take a look at this. kubeadm config node. So you can see the service subnet is 10.49/16. We've got a pod subnet at 10.48. I'm actually installing from my private registry, reg.calico.fun, and I'm using IP tables mode. So let's come over here to the instructions, and we're just going to go ahead and initialize the master. Wrong direction. Boom. All right. So let's initialize the master. All right. Now I was having trouble with the authentication to my private registry, so hopefully this works out for us. We will see. Fingers crossed, and tip of the hat to the demo gods. All right, so you can see that we've been able to initialize the master, and what it's done is it said, hey, we've created a kube config that's going to allow you to talk to your cluster. Please copy this to the default location that kubectl looks for it. And also here is the kubeadm join command that you're going to want to add to each one of your worker nodes to be able to join it to the controller node. So let's do that. Let's do this. So let's copy this kube config into place. I'm going to override the last time I did this, and then we're going to copy this here, copy that join command, and let's do this. So kubectl get nodes -o wide. Let's see. All right, so right now we only have the master, and you can see that it's 10.16.1.11. All right, so let's come over here to Ubuntu 2, and let's join it to the controller node. We're going to let that go. And we're going to come over here to Ubuntu 3, and we're going to join this to the controller node. And then we're going to come over here to Ubuntu 4, and we're going to join this to the controller node. And then we're going to come back here, and I'm going to hit enter a couple times, and then we're going to take a look and see what are the nodes. And you can see them as they come up. They're slowly but surely joining, and where it looks like we're just missing one more node. All right, cool, we got them all. We've got 10.16.1.2.3.4. They're all here, and typically they would come up as not ready until we install Calico, but that's okay. I just had done this a little bit earlier. So if we come back over here to our instructions, the next thing we're going to want to do after this is we're going to want to start off the installation of the Calico. Well, let's take a look at what's running first. So kubectl get pods -o wide -A. All right, so we can see that by default, we've got a KubeProxy for every node. So that's a way we can see that things are working out here. We've got KubeProxy for every one of our nodes, the controller node, and then all the workers. And we've got core DNS, which provides DNS for the cluster, but that's not going to come up until it can have an IP address assigned to it. And Calico is going to be the thing that assigns those IPs. So now we have to install Calico. So if we apply the operator, all right, then what we're going to do after this clear is take a look at the custom resources config. So if we come back here to the quick start, you come down and you'll see we're following the same path. We've got the kube in it. We've initialized our cluster, copied our stuff over, and we're doing the operator, and then we're doing custom resources. And then we're going to taint the nodes, remove the taint actually, and then we're going to look at the nodes and see that their statuses as they come up. And you can see it's a very similar thing here. In the past, I hadn't used a private registry. So if you take a look at the kube config here, or excuse me, the custom resources.yaml, you'll see that I've got my private registry. So this is how you can say, hey, we want you to pull your containers from your images from this specific registry. And this is very typical. This is something you're probably going to have in an on-prem environment in your data center. A lot of teams are not going to want you to just be pulling stuff off of the internet. You're going to say you're going to have some registry on-prem, Artifactory or Docker registry or what have you. And you can see I've chosen to, we're going to pick 10.48.1.0 is going to be our default IP pool CIDR, and it's going to have IP encapsulation across the nodes. So let's go ahead and do that. So let's just check out and see what's running. Get pods minus A minus O wide. And you can see, oh no, my operator is not starting. Let's look and see. Minus N. Let's look and see. I bet it's the authentication. Let's see. No basic auth credentials. All right. Let me do this real quick. Too. Wide. Let's see, what node are you on? You are on 2. 2 is over here. So what I'm going to do is cheat. I'm going to cheat so we don't have to troubleshoot the credentials. Let's see. All right, good. All right, we are in business. Now let's do this. Let's see. So now we're going to apply the custom resources. Create custom resources.yaml. All right, and with any luck, we're going to start to see Calico coming up. We're going to see Calico, and let me try to remove the O wide, see if we can see this better. Oh, actually, you know what I can do? Make this a little bit bigger. All right, we can start to see Calico. The operator is going to bring up Calico node, and Calico node is going to get assigned to each one of the physical nodes that we have here. Ubuntu 1, Ubuntu 2, Ubuntu 3, Ubuntu 4, and Ubuntu 1. So all the masters, all the worker nodes are all going to get a Calico node pod via the Calico node daemon set. So if you're doing auto scaling in the cloud, or you have some way to do that on-prem with bare metal nodes or VMs, every time that you expand or contract your cluster, that's fine. Calico is going to make sure that Calico node is placed there. And what's going to happen is it's going to be able to assign IP addresses to the different pods that are there. The first two that are going to get IPs are core DNS. So let's see, how far along are we? All right. And so let's take a look at minus O wide. And you can see that these are all host networked, and so these are IP addresses of the nodes, but you can see that Calico or core DNS has gotten an IP address out of that CIDR that we have. So 10.48.1.193. So let's come back over here to the walkthrough, and we'll just take a look at some of the observability that we get with Calico Calico cuddle. Keep doing this. So I'm gonna make this a little bit bigger. So if we just take a look and see, hey, what are our nodes? So you can see that right now, our cluster is up and we have a full BGP mesh between all of the nodes. This is facilitated across the IP tunneling that we have set up in our cluster. If I do if config, you'll see that we've got a ton interface here, and this is what allows us to do the tunneling from node to node across these network segments. If we come back to the tutorial, I want to take a look and see what. Let's take a look at that IP pool. So you can see that here we go. We've created our first, the initial IP pool. It's not using the entire pod cider. It's using a small part of the pod cider, and that means that we can have more than one of them. So I could have 10.48.1, 10.48.2, .3, .4, .5, and I could assign those the namespaces, and that allows you to mix and well to have well-known IP addresses inside your cluster, should you want to be able to do that. And then we're also doing NAT outgoing true. So my cluster is currently private. What we'll do in the next time that we do this is we'll disable this and we'll peer to the top of rack switches. I didn't have time to do that for this this demo. And then lastly, let's take a look at the Calico network policies. Well, here, I'll show you the IPAM blocks first. And then, so you can see that we've got an IP pool 10.0 or 10.140 or 10.48.1.0/24, and out of it we've broken out /26s, which are the default block size, and you can see that there's 4 of them, and that's because there's 4 nodes inside of my cluster. So by default, you're going to get a /26 assigned to each one of your nodes until they're gone, and then you would need to create another IP pool. And we can look a little bit further into the utilization. Show blocks. That's what we just did. All right. So now let's take a look at the Calico network policies. So by default, there aren't any network policies. Everything can talk to everything. And one of the earlier in the slides were like, why use Calico instead? And what's better about Calico network policies instead of Kubernetes network policies? One of the things is that you can create Calico policies that not only apply to individual namespaces, but they can apply to the entire cluster. So you can say, hey, this entire cluster is not allowed to talk to anything. So you start off with a default deny policy. And then you can say, all right, I'm going to allow inbound access. I'm going to allow outbound access, and on a case-by-case basis. Kind of start off with like the zero trust network paradigm. Or maybe you want to implement the zone-based architecture that we're going to apply here. And I'll show you what the policy looks like in just a moment. All right, so we've applied that network policy. And so now if we look at the network policies that are running inside of our cluster, you'll see that we've got the DMZ, the restricted, and the trusted zone. And what the YAML representation of a network policy, it looks like this. You can see it's kind network policy. We have network policies, we have global network policies in Calico Enterprise. We also have staged network policies, and some other things that we have that, well, anything that you do with Calico Enterprise pretty much has a YAML representation of it, which it allows you to manage it in code with CI/CD, your GitOps methodology. This is a network policy, and you can see that what this network policy is named DMZ. It applies to all of the endpoints that have the firewall zone equals DMZ, and what it's allowing inbound access from 18.0.0/16, and then it's denying everything else. And it's allowing egress access inside of to the trusted zone and also to the logging application. And then we have a trusted zone. We're allowing inbound access from the DMZ. We're also allowing everything inside of the trusted zone to talk to each other. We're allowing outbound access to everything inside of the trusted zone, and then also to the restricted zone. And this is just an example of a microsegmentation pattern that you're going to see implemented in a data center that we've implemented inside of the cluster. So we're at time. I'm going to stop here, and I'm going to kind of go back through some of the questions here. Let me see, just starting from the top. Is there a demo showing network security management to Kate's from Palo Alto? Maybe. I'm not positive if we have that published or not, but if you're interested in seeing that, shoot us an email and we could set up a time to set up a demo. There definitely is for the Fortinet integration. There's one on the Fortinet site. I don't have the link handy, but if you hit us up via email after the training, be happy to show you. There's also BGP between nodes, BGP externally, and WireGuard encryption. Yeah, we do. We have WireGuard encryption as well, node to node. It's super fast node to node encryption. It's actually like, I think it was 6 times as fast as there was a third-party assessment of all the CNIs, and as far as encryption goes, it was 6 times faster than the next runner-up, but I think was using IPsec. When do we use BGP peering and when the network encapsulation? So if you're doing IP, you're using network encapsulation, but there's also BGP in being used as well, but you're not peering with top of rack switches. So you're not using BGP peering yet. If you're using VXLAN, you're not using BGP at all. There's certain places where you can't use BGP, like specifically Azure, and that's where you'd want to use VXLAN. But if you're running on-prem and you have top of rack switches that you can peer with, then you can set up a BGP peering with your top of rack switches, and then you can turn off encapsulation. And that when you peer your top of rack switches, you can route packets across the different network architectures that you have. If you come to docs.projectcalico.org and you scroll down in our reference section and you look at network design and you come to IP fabrics, you'll see that there's a couple of different well-known architectures that we have. We have an AS per rack model. We also have, a lot of people do AS per compute server. And then another popular architecture is the downward default model. And if you're doing Calico Enterprise, we also have the ability to peer with 2 top of rack switches. And what that allows you to do is have redundancy inside of a rack. So if you're upgrading the operating system of your top of rack switches, and you don't want to lose the capacity in a rack, you have redundant peers inside the same rack. If you're changing the passwords from time to time for your top of rack switches, stuff like that, this allows you to have a redundant pair of top of rack switches inside of a rack. And this is something that's productized as part of Calico Enterprise. One of the other things I wanted to talk about before we finish though, so we have the Introduction to Kubernetes Networking ebook, we have the Calico certified, the Calico certification, and you can try Calico Enterprise for free. If you sign up on tigera.io/trial, you can try out all of the enterprise functionality, either in our hosted environment or on-prem in your own environment. Let me just take a couple more questions. Is there a Calico integration with Checkpoint? I definitely think that we may be talking to them on developing that. So if you're interested in that, let us know. Calico, or Tigera, we are an open source company. We deliver major product releases every 6 weeks or so. So we move really quick. So if you're interested in having something like that, reach out, let us know. We'll put it on the roadmap. Is there, let me see here. If I'm using Calico network policies, what's your opinion on using OPA also? Well, if you're using Calico Enterprise, you have access to our API, and that enables you to do OPA, and that would allow you to do OPA checks on things like labels. Maybe I want to say, hey, I want to ensure that all of my network policies have all of these labels. That's a great way to do that as part of like a CI/CD process. So, I mean, a lot of people will manage the policies in code, and they will apply them via CI/CD in like a GitOps model. And one of the things you could do as part of that build process is have OPA checks run and say, hey, are all the labels that I require part of these different labels? Also, with Calico Enterprise, you can, because the things like whether or not encryption across all of the nodes is enabled is managed by code. You could have OPA checks that say, hey, the configuration of all of my clusters, I want to ensure that encryption is turned on all of my clusters. And I can say, hey, the only way that we bring up clusters is via CI/CD. We have OPA checks that say, hey, I ensure that encryption is enabled. And that's a checkbox for us that, hey, we've got encryption taken care of. And we know that's the case because our OPA checks ensure that that's the case. If you start off with the community, is the upgrade to enterprise seamless or reinstall? It's seamless. For certain certain distributions, if you sign up on Tigera, the Tigera trial, you can actually, if you sign up for the trial, one of the options is to install Calico Enterprise in your cluster on-prem. And what it does is it calls out to our management UI in the cloud, and you can use our management UI, and what it will do is automatically upgrade your cluster to Calico Enterprise, and you can try it out from time to time, or for a certain amount of time. And yeah, it's seamless. If you look at the Tigera .io trial, you'll see the different automated clusters that we have. And then just real quick, this is Calico Enterprise. Let me see here, I'll just refresh and just kind of show you what the UI looks like. This is the overall stats dashboard. You can see that you get like how many policies, how many endpoints, how many nodes, the connections per second, the allowed bytes, allowed packets. You can see I've got some denied traffic here. You can see the packets per policy. Right now everything's all green. If there was something being denied with certain volume, you'd see there'd be some red. You can see all the policies and our policy tiering. If you come over, you can see how you can graphically manage network policy. So if you don't want to manage things in YAML, you have a GUI to manage it. And then if you want to manage it as YAML, you can just do it in the GUI and then edit it as part of your IDE. So you can create the policies inside of the UI and then manage them as YAML after the fact. You get a timeline for all the changes that happen inside of your cluster. If Joe and Bob and Jane are making changes in the cluster, you'll know what did they change, when did they change it, what were the changes. You can see all the endpoints in your cluster. You can see whether or not they're Linux, that the cluster nodes themselves or the Kubernetes nodes. We have like a flow visualization tool that allows you to visualize the flows in your cluster, and you can visualize them by names, colored by namespace, by name, or by whether or not there's allowed or denied traffic. And you can see, like, look for denied traffic. You can see there's very little bit of denied traffic inside the storefront namespace, and I can drill in and I can see specifically what is this denied traffic here. And it looks like that the front end service is being denied the ability to log to the logging service because I have a bug in my policy. We also have compliance reporting, and we have automated alerting and IDS capabilities. If you want to get a demo of Calico Enterprise, feel free to sign up for it on your trial, but reach out to us and we would be happy to give you a demo. And so I will leave you with that. Thank you much for your time. Thank you for spending a little, I've gone a little bit over. Thank you much for all your time. Sorry if I didn't get to your questions. If I didn't, feel free to ask them on our Slack. You have a great day. Happy New Year, everybody. Thanks for your time.